everyone. I'm here with Justin Clifton, currently, as of September 2021, a student at Western Carolina University. Justin has extensive experience. He's both a math and CS double major, and he's done a lot of work connected to actually helping companies do things. So I'm not going to talk about all of your projects, but you're not speaking just from theory, you're speaking from experience.
I do have some experience, yes. I would like more, but
So I wanted to talk to you today about functions because functions are, I think, one of the most crucial yet misunderstood concepts in math and computer science. I think a
yes.
lot of people, when they think of functions, are just like, oh, I know this, f of x equals x squared. But there are lots of different ways to think about functions, and that's what I wanted to talk to you about.
Yeah, very important across all of computer science and math, just like you said. Definitely a crucial idea.
Let's get started. I've got Jupyter Notebook. Do you like Jupyter Notebook, by the way?
Love Jupyter Notebook.
What
Yeah,
do you
they're
think
good
are
for they are good for specific use cases, not great for like large scale engineering stuff, but like for like simple analysis or just doing data science work, I love Notebook. I love being in the read, evaluate, print loop. I think it's a really good way to learn, and I think it's a really good way to work.
So I'm going to type up what I think of as the definition of a function from a precise mathematical viewpoint. A function has three things: a domain, which is the set of possible inputs; a codomain, which is the set of possible outputs; and a rule that assigns each element in the domain a unique element in the codomain. That's the pretty standard definition. So is there a way that we can work on understanding this better?
I mean, I think that the best way to understand them is to work with them. I think it's a good idea to just get your hands dirty, especially in Python, since it's so easy. I think that's probably the best way to understand a function.
All right, let's create a function in Python. Pick a function that you like and let's make one.
I think a very simple one to start with is we could either do the classic printing hello world, or we could do a classic just square function,
Let's do
passing a
square.
number.
Yeah, let's do square. Let's implement f of x equals x squared. I'm going to call this function square. I like to have suggestive names.
In Python, of course, you always start with the def.
Def, then the name of the function. So I need a colon here. And then it did it for me automatically, but if it didn't, I need to be sure I have the white space down here.
Yes, indentation in Python, very important. If you mess up your indentation, Python will not like it. And that's one of the few things that we'll complain about.
So now, well, it's pretty obvious what to do here. I just need to multiply the number by itself, x times x. Will that work?
Well, yeah, that would give you an answer, but of course, what are we doing with that answer? I don't remember in Python, does it return automatically without keyword, or do you have to
I,
explicitly put that?
I'm suspicious if, I don't know if it does or not, so why take the risk?
Yeah, why take the risk?
So return is what the function gives back. So I think this is something that differentiates beginning programmers from more experienced programmers, because beginning programmers tend to think of always having a human in the loop, and so they might be tempted to print x times x or not worry about returning, whereas
Right.
more experienced programmers understand that these are building blocks, and when they run this, they will have chains of dozens of functions that no one will be looking at the results. It will all be automated.
Right.
So
And
go ahead.
there are a lot of reasons why you want to use functions. The big one is encapsulation of logic. If you have this square function, for example, you can pass anything in for your x, and you'll never need to rewrite this logic. And if you ever use this logic somewhere else, you'll have to go to a place where you can change it in this one place, as opposed to like, say you accidentally type x times x times x. Well, if you did not have it in a function, you would have to manually go through your code and change it everywhere that you use that logic. Putting it in this nicely contained function, you can just go debug it in one place, and then the result will change everywhere else in the code that you use this function. So that's just one really big one. You want to make sure that, as opposed to just like typing out the logic every single time.
And it can be tempting to, sometimes people they run fast, but they go slow because they just copy paste code. They're just trying to get something moving. They get in this like adrenaline rush mode where as long as they're seeing something happen, they're happy. And what thinking in terms of functions does, it's really important, is it makes you go up at a higher level and actually think about what you're doing. And that's often seems slower because you don't have that frantic adrenaline rush, but I think in the long run, you write cleaner code better.
Absolutely. And it allows you, the other nice aspect is that it allows you to dissect your problem. So you can think about it in terms of bits. Say it wasn't something as simple as squaring a number and you had more complex logic. Well, that's when functions really become you because you can chain together different steps of logic that you solve the problem. And thinking about it functionally, thinking about it in terms of function, help you split the problem into pieces and work through it.
That's a really good point. Let me type that out. It also connects to unit testing really well.
Yes.
In fact, I mean, I personally feel that almost all of the best coding practices are exactly the same thing as the best practices for like reading papers. Because what do I do when I read a paper? If I read a definition, I immediately see if I can construct an example and a counterexample, which is like unit testing. It's all right. So we have this. I want to connect this for a second to if I were writing this out in actual mathematical logic, I would need to specify my domain and my codomain. Let's say this works only on integers because most things in discrete math are integer based. So I'm going to take an integer and spit out an integer, right? I have integer input and integer output. And the notation for the saying that x gets mapped to x squared is this arrow with a line on the end. So if I wanted to actually be careful and say what my domain, what my codomain, and what my rule were, I could do that here. Is there a way to express that information in Python? I think there is.
I believe there is. I don't know the syntax off the top of my head, but I do think that there is. It's not really typing, but it's like soft typing.
If I'm remembering right, I think the way this works is you take a colon and then the type afterward,
I believe that is correct.
and then you do sort of an ASCII arrow with a hyphen greater than, and you say what the output type is.
Right. And it's important to remember that this is something that occurs, not to get super high level here, but this declaring your domain and your codomain is something that occurs in almost every other programming language. Certainly any typed language. You have to
Yes.
declare what you're going to return and what you're taking in.
So like Java, if you were doing this, you would have to do like int f, int x, or something like that.
Mhm.
So most other languages are going to enforce this domain and codomain. I haven't done Java in a really long time, so I hope that that's close to right.
That's close. That's close to right.
So that works really well for functions. If we have a formula, we can just say what the formula does. By the way, I like x times x better than x squared because it's faster.
I think it would be good to show them the function and work. Pass it some numbers and see what it gives us.
So let's do square 3. I have to make sure this isn't a code cell. By the way, I don't remember if I do markdown and I want to go back to code, how do I convert back to code?
I don't know the hotkey off the top of my head, but I think it's
So if we actually want to square 3, we have 3 is squared, and we get that the answer is 9. So that's pretty straightforward. If you have a function expressed as a formula, then it's really easy to express a function as an arithmetic formula. And that's probably what we're mostly used to. We're used to like polynomials that have nice symbolic descriptions. But that's not the only kind of functions there are. I'm curious now, what's another kind of function we could write?
you can have functions that are not necessarily pure. You could have ones that print information user. You could have ones that have more complicated logic. Like I think I had a function recently in my internship that did everything from partitioning my data frame to also like relaying information about where I was at in the fitting of my model process. So you can the complexity you can have with functions can be very complex. Obviously, you prefer to keep them to smaller containable pieces of logic, but you can certainly get as complicated as you want with.
So what if I have an idea. What if we have a function that takes as input a set and then returns some information about that set?
Sure.
So one that pops to my mind is that there's the maximum function. And maximum is interesting because if you think about the function max, what is the domain of the maximum function? And we'll again assume that everything here is an integer because of this class. But What is the domain of the maximum function?
I would think, I didn't implement this, but if I had to guess, I would think that it is technically initerable. So the function could probably take an iterable of integers. To keep it simple, we can say a collection or a set or something along those lines.
Yeah, I think keeping it as a set or a list, I mean, for Python, you could say something like sequence like, but from a mathematical perspective, it works to think of it as a set. And if you didn't think of it as a set, you could write a function that just converted anything to a set and feed that first, right? So from a mathematical perspective, the domain is all subsets of the integers. And that's weird because our domain here is a set. Our domain has to be a set, right? But our domain is a set of set.
Very powerful idea.
Is that too weird?
Not weird for me, but it is a little tricky to wrap your head around initially. Sets of set.
Was it weird the first time you saw it?
The first time I saw it, yes, it was. Set logic in general was kind of an interesting introduction to a rabbit hole of topics, right? Because that this idea of sets gets complicated pretty quickly.
It
there
does.
are there are some there are some very interesting theorems about sets of sets, and they're really important theorems too. And but for programming's sake, it's as simple as thinking of a list of lists. It is quite similar. So from a programming standpoint, it doesn't have to be complicated.
Yeah, I agree. I think anytime you see a set in math, even though technically lists and sets are different, if you think of it as a list for just a little bit, it can be helpful. But this max function doesn't have a formula. I mean, it is like a basic operator. There's no arithmetic formula for it. Instead, what we have is a description in Word. It's just the input is a set and the output is the largest element in that set.
Could be a good time to introduce some doc strings. Important idea in Python functions as well.
All right, so let's write a max function. So def, and I'm going to call it my max because I know that there is a max function and I don't want to clash with it. And now I'm going to say I'll use x again and I'll ask it to be a set. And then the output should be an int. And now you said doc string. So tell me how to make a doc string.
So you want to do triple quotation marks. And in terms of like the specific details of how you do this, that's a little bit up to choice. How I like to do is I will colon and then I'll type the word param and then I'll put the name of the parameter and then another colon and I'll describe what that parameter is. So in this case, it's a set of integers exactly. And then above where I'm putting and then I also like to do a colon and then return, and I'll put a closing colon, and I describe what this function is going to give, like what is the resulting value that this function should give them exactly. And then above these, I like to put a little description of the function. So above where you have param x, I might say something like this function takes in a set of integers and returns the largest integer.
I think it's really good to do this because you can do this even if you have no clue how to compute the thing or calculate the thing you're computing. So I may be totally stuck on what's the logic of coming up with a maximum function. I may not know how to do that, but I can still write this description for myself. And then it's like I've made some progress. And I may at some point pay someone smarter than me to do it. And then they're going to need something like this to get started.
At the very least, you have your problem defined.
Yeah, you're right. You're right. Defining the problem. You have your problem defined. And often that's the big challenge. Thank you for that.
And it's also useful documenting your code also because it might not be obvious when you come back. Like say you're working on a project and you leave it, you come back and you have a function or a series of functions. It's not always obvious, even though Python is very English-like. It's not always obvious what your goal. It's not obvious what you were doing. It's not obvious why you were doing it. As much as we would love for it to be as simple as like you look at the code and immediately you understand everything that's going on, that's just not always how it works. And if you pass the project on to somebody else, they'll be able to look at least what your goal with the function was. Even if it has some sort of bug in it, they'll be able to tell, well, this is at least what you were trying to do, and maybe they can look at it, fix whatever problem you had, or you can look at it later and fix whatever problem.
So